All right, we only have two learning goals left. One of them says I can graph exponential growth functions, and the other one is I can graph exponential decay functions. Today we're not actually going to do any graphing, but I have to remind you about something that we did a while back, or maybe even just a little bit before Christmas, and we talked about negative exponents. Okay? Don't write this first one down. Let's just talk about a positive exponent. Remember that if we had something like this, 3 squared, that is the same as 3 times 3, right? Well, 3 times 3 is 9. All right? If we had something like this, if we had 2 cubed, that is the same as 2 times 2 times 2, right? Well, 2 times 2 is 4, times 2 is 8. All right? So that's how we dealt with positive exponents. Negative exponents are interesting, but they're also really important, okay? And so let's look at that real quick. All right, so when we're talking about negative exponents, if I said something like this, 3 to the negative 2, all right? A lot of people think, oh, Mr. Palin, 3 squared, that's 9. It's a negative exponent, so it's negative 9. Nah, do not write that down. That is not correct. Okay? 3 to the negative 2 is this, and this is somewhat surprising, but that negative exponent actually means that this number belongs in the denominator. So what it really is, it's 1 over 3 squared. Okay? And now that's a little bit of a hard concept to see. Back in the day, I went through a whole logic of why that's true. And maybe I'll do that logic one more time, especially for some of you parents that are watching out there. Okay? But anyway, the negative exponent, put it down in the bottom. So then 3 squared is 1/9. All right? So what if I had 2 to the negative 3rd power? Well, anything raised to a negative power goes down to the bottom, so it's 1 over 2 cubed, which is the same as 1 over 2 times 2 times 2, which is the same as 1/8. Okay? And so that's not even a negative number. 1/8, what is that? That's like 0.125. It's not even a negative number. It's a small number, but it's not negative. Now that surprises people, and that kind of bugs people. How does that work? I'm going to show you here in just one second. All right, this is the best example I have of why a negative exponent is the same as just putting it in the denominator. Okay, let's look at the pattern here. So this is all based on tens, and we all kind of understand tens. 10 to the 3rd power, right? That's 10 times 10 times 10. 10 times 10 is 100. 100 times 10 is 1,000. Bam, we all know that. Okay? 10 squared. 10 times 10, that's 100. Bam. 10 to the 1 power. Well, anything raised to the 1 power is itself 10. 10 to the 0 power. Remember when we talked about this? Anything raised to the 0 power is 1. Okay, that confuses people, but that just is what it is. X to the 0 power is 1. Anything raised to the 0 power is 1. Okay? So we have a pattern developing here then. And the development of our pattern, you can see, okay, 10 to the 3rd power is a 1 with 3 zeros. 10 squared, 1 with 2 zeros. 10 to the 1 power, 1 with 1 zero. 10 to the 0 power, a 1 with no zeros. Okay? Also, you can see that the decimal place is being moved back each time, right? One less decimal place. Okay, so now all of a sudden, what happens when we go from 0 to negative 1? Well, you just move the decimal place back 1. And so really what that is 1, how do you say that number? 1/10, right? How do you write it as a fraction? 1 over 10. Well, 1/10 is the same as 1 over 10 to the 1 power. So notice the negative exponent, put it in the bottom, it's the exact same thing. Okay, so here you have 10 to the negative 2. Again, what are we doing? Just moving the decimal place back 1, right? Bring it back. So we have a 1/100th, right? 1/100th, that is the same as 1 over 10 squared. Finally, 10 to the negative third is the same as 1/1000th. It can be written like that, which is the same as 1 over 10 cubed. So it actually works for any number, not just base 10 numbers, but you can see the argument for that. Okay, and that's about the best argument that I have. So if you don't understand that, that's okay. At a certain time you will, but as we head into this next assignment and the following assignments, you just got to trust me. And I'm going to be saying it over and over. If it has a negative exponent, move it to the bottom. All right, now you either need to be able to print the worksheet or you need to be able to look at it. And if you can't watch this video and look at the worksheet at the same time, go back to the worksheet and just copy down the odds. Okay, so just make a list going down the side. 1, 3, 5, 7, 9, 11, and just copy those problems down. We're going to actually do a lot of those problems together right now, so I need you to have them written down. Okay, so take a minute to either get the worksheet printed out or just copy down just the odds right now. You don't need to copy down the evens. I know this worksheet is 24 problems, but it's going to go pretty fast. You're going to see that. Here we go. Problem number 1. Okay, 8 to the negative 1 power. All right, how do we get rid of the negative 1 power? Put it on the bottom. So here we go. 1 over 8 to the 1. Well, 8 to the 1 is just, oops, it's just 8. So it's just 1 over 8. Okay, bam, problem number 1's already done. Okay, this assignment isn't going to take too long. Okay, let's jump to problem number 3. It's y to the negative 7th. Tani, what do I have to do?
Put y7 on the bottom.
There you go. 1 over y to the 7th. Okay. You have to remember, Tani hates math.
Mm-hmm.
I don't know. She's my daughter and she hates math. How does that happen? But anyway. I'm
better at English.
So anyway, so now what if we did this one? 3x parentheses to the negative 1. All right, now, this whole thing is raised to the negative 1 power, okay? So the whole thing goes to the bottom. So it's 1 over 3x. All right? So it goes kind of fast, doesn't it? But anything raised to a negative exponent, you just transfer it to the bottom, solve. This one who knows what y to the 7th is, right? So we just leave it. 3x to the negative 1, transfer it to the bottom. I could put this whole thing in parentheses to the negative 1, but you don't have to do that. All right, we'll look at a few more. All right, so as you can see, number 5 here, we'd already done this one, but to the negative 1, bring it to the bottom. 3x raised to the negative 1. That's just kind of just a little step that I skipped. I just want everybody to see that. Anything raised to the 1 power is just itself. So, all right, now what's the difference between number 5 and number 7? Well, there is no parentheses. That's the difference. So really what's happening here is only the c is being raised to the negative 3rd power. All right, so the 4 is not affected. The 4 stays on top. The c, the c goes to the bottom. Okay? And then that's your answer. Do you see the difference though? In this case, both the 3 and the x came down. In this case, just the c came down. We don't know what c to the 3rd is, so there's no evaluating that can be done there. Okay? We're going to skip number 9. I'm going to go to number 11. You guys can do number 9 on your own. Okay, number 11. Okay, this one's interesting. It's 1 over x to the negative 2. Now, wait a minute. Now, the negative exponent is in the denominator. It's actually really simple. Bring it up. X squared. That's it. So if the negative is in the denominator, move it up to the numerator. Okay? We're going to skip 13. You guys can do that one. We're going to go to number 15. And 15 says a to the negative 1 over b to the negative 1. Oh, well, a to the negative 1 is negative exponent, right? Comes down to the bottom. A to the 1. Negative exponent in the bottom moves to the top. B to the 1. Okay? B over A is your answer. So, that's not really hard. It's really not hard. You just have to, just remember, if it's a negative exponent, it goes to the top. Okay, we'll do just a few more examples, and I'm going to turn you loose on the assignment. Okay, so I got just last two examples, and then I'm going to turn you loose. First one I like about this is this negative out front. Well, that negative out front really means nothing. So we're just, at the very end, I'm going to make it negative, okay? All right, so here, what is raised to the negative exponent on this one? Is it the x and the y? No, it's just the y, right? So I'm going to go x, right? And my 9, is it being raised to a negative exponent? So it's going to stay on the bottom, okay? Now, my y to the negative 1, negative exponent, I'm going to move it to the bottom. And it becomes a positive 1. Okay? And then a z to the top, z squared. A few years ago, I had a kid say, Mr. Palin, this division sign filters out the negative. If you push it through, you lose your negative. If you push it up, you lose your negative. And I thought that's kind of a good way of looking at it. But really, in a way, you're done there. You don't have to have this 1 power there. You could just have it like that. But that's done. Now you don't have any negative exponents left, right? So anything that was raised to a negative moves to the bottom. Anything raised to the negative on the bottom moves to the top. Oh, what did I almost forget? I almost forgot our negative side, didn't I? Dang it. Well, I'll just squeeze it in here real tight. So that negative right there is right there. Yeah, it can be top, bottom, or middle. All right, now let's look at this one. What is being raised to the negative power on this one?
All of it.
Okay, so the whole thing goes to the bottom, doesn't it? So it's a, b in parentheses to the 1 power. Okay, and now what's being raised to the negative on this one?
D.
Just the d, so it just moves up, d squared. Now, don't forget, I still had a c there, so I should be wiggling it in somewhere here. I think I'll put it right over here.
That's an A, Dad.
In the problem, that's an A?
You have A on top instead of a D.
Oh, thank you. D. Thank you. Okay, so d squared goes on top. That c right there is just that c right there. So really, I have, if I simplify this down, I don't need those parentheses since I'm just raising it to the 1 power. So I have d squared equals, another way of looking at it is you can distribute that 1 to both parts. So it's a to the 1, b to the 1, c. And I really, if it's only raised to the 1 power, I don't like to have those. So it's just d squared over abc. Okay? All right, folks, you got enough information now to do that whole worksheet. Okay? Also, I have included the answers. So, well, Mr. Palin, I could just copy down the answers. Yeah, you could. And send it in to me, and, you know, that'd be that. But, as you know, I want you to learn, right? So you're way better off trying to do the work yourself than check your answers. We're getting to the time of the year now where I really only have 2 learning goals left. I mean, you can jump through the hoops, you can fall this far. Or you can say, hey, I know I'm going to be seeing this stuff next year. I might as well learn it now. That'll make next year easier. Okay? Anyway, either way, for me, I'm trying to do my best. I encourage you to try to do your best as well. So just to make it clear, I want you to do the whole worksheet. I want you to check your answers after you've done the worksheet. And then I want you to take a picture of it and send it to me. Hopefully it doesn't take very long. If you're not sure why you're getting the problems wrong, feel free to call me. And we'll go over it. 406-651-9072.